is Pablo Linares. I'm going to show my demonstration of the assignment 3 for distributed systems course. For the exercise 1 and 2, I just modified the closing of the ports of the sockets at the end of the scripts in each one of the scripts. For example, here in the UDP echo client and UDP echo server, I just added at the end close method, and the same here in the server side. I added a try and accept statements and close method at the end. Okay. Now I'm going to show the output of each script, the echo client and the echo server. First I run the echo server and then the echo client. Okay, so the echo client has finished. So now to stop the echo server, just I have to send a keyboard interrupt and the program stop without throwing an error. Multi-threaded server and multi-threaded server, the client side, I also added the try and accept statements, and at the end close method, the same here in the client side. So now I'm going to run. First I run the server. So now the socket is listening, and then this ask me for a message. So I just put. So now the client is still asking me for an input. So first I'm going to stop the client using a keyboard interrupt, and the program stopped without problems, and the same with the server side. Okay. For the multicast example, I put try accept statements again, both in the sending side and the receive side. So this is the running of these scripts. First the receive, then send, and then the receive side is still waiting to receive a message. So I just close with a keyboard interrupt. Okay, this is the exercise 3 to create a calculator server. So here, this is the server side. First, I create a class called db calculate server. For TCP, just create a socket, and then a method start listening. First bind the socket and then start listening with the method listen. The other method is accept instruction, which just ask for or receive an instruction and create a thread to perform the instruction. Then the method check instruction just check the operands here. First check here if the operator is in this list. plus minus product divide or remaining, and then just perform the operation, and then the method send response just send the result to the client. So this is the main thread. First, the server start listening on the local host in this port, and then begin in an infinite loop to accept several instructions. In the client side, I just specify how many clients I want to how many clients I want to create. Then I also define an operator list here, and then just create clients in the form of threads also with the thread full executor context manager. Show the execution of this exercise, the TCP version. First I run the server side, and then the client, and this is the instruction with the operands and the result of the operation. So now it is creating 100 clients. Okay, here we can see that the instruction is this, and the result is this. So first the operator, and then the two operands. Okay, for the UDP version is almost the same, just there is some instruction that I have removed. For example, to start listening, I just bind the socket to a socket to address and a port, and the self-socket listen, no, I don't put it because it is just for TCP, not for UDP. The remaining is almost the same. It's almost the same. Yeah, and here to initialize the socket, I had to put the sock datagram to specify that I'm using UDP. On the client side is the same. I specified that I'm using UDP here, and the remaining is the same. So now I'm going to run the scripts. First I run the server, and then I run the clients, and as we can see, this is the same behavior as the one of TCP version. Okay. For the final exercise, this is two scripts. These are two scripts, a multicast sender and a multicast receiver. I didn't change the example too much. I just added a for loop here to send different data to multicast receiver. So I just going to run the scripts. First, the receiver is waiting to receive a message, and then the multicast sender, and that's all the messages. Message 0, message 1, 2, 3, until message 9.